Good morning, fifth graders. In your notebooks, you should have all of these terms. Oops, hold on. Sorry about that. So you should have standard expanded forms, rounding, estimation, greatest common factor. Another term for that is, let me write it, GCF. Lowest common multiple, LCM. Prime factorization, multiplying by 10 hundred thousands, dividing by tens, hundreds, thousands. When we ask you to do it, to write a number in standard form, that's just written in numbers. So if I say write 542, 542. If I say give me 50 tens, see if you can figure out what 50 tens is going to be. If you said 500, you're right. Sometimes on the test and the review, they're going to try to trick you. They're going to say 50 tens. Well, 10 is the 1 0 here, put 50. If they say 65 hundreds, that's going to be 65 and hundreds, so 6,500. When they ask you to write in, sorry, I'm not liking the gray, but I might just have to deal with it. When they ask you to write in expanded form, remember that means to expand it. So now you're going to take 1,000 and have all the zeros, plus 600, plus 200, 600,000, 220,000, 4,000, 500, 60, and 0 ones. That's expanded. When you are asked to write in written form, remember you are only going to use letters. There's not going to be one number in there. Don't put 600. Nope, you have to write out 6. So 1,624,560. For the test and review, let's write them all out because it's kind of a formal way. During your practice, I always let you put thou. Let's write that all out though. 1,000. You're going to be taking the test on your English day. And on the review, practice it. And if you don't know how to spell a word, I'm sure on the sheet there'll be the word and how it is spelled. I know, Mrs. Berger's a really strict teacher, right? Rounding. If they ask you, you have to be careful. They're not always just saying the last digit. They might say to round to the nearest 1,000. So what I would do, let me erase this. I would erase the place value that they are asking you to go to. So ones, tens, hundreds, thousands. So this is the one they're wanting us to round to. We look to the right. We look to the number before. And does 8 have enough power? Yes. 8 has enough power to round it up. So it's going to be, you're going to make this a 3. Right here, 13,000. Here are the exact steps if you want to go through them. Find the digit in the thousands. Look to the right, one digit, and decide if it makes the number stay same or bump up. Keep all numbers before, that's why we kept the 1 there, the same. Change the thousands and add zeros for the rest of the remaining place values. Now if I said round, hold on, let me erase all this. I'm going to say round to the nearest 10. What you would do is you would find the 10. Here's the 10, 6. You look to the right. Does 3 have enough power? Nope. So it's going to be keep all the numbers the same. And do we round it up? No. And then add zeros. So make sure to find that place value that they're asking you to round to. Estimation, using numbers we know to round big numbers. This is when you get to choose, when you get to decide what facts do I know and change the numbers. It doesn't have to be round to the nearest tens, hundreds, thousands. You can round it to whatever makes sense. For example, in 54,862 divided by 7, okay, keep this number. look at 7. Well, what does 7, if I use my multiples, 7, 14, 21, 28, 35, 42, 49. Ooh, 49 is pretty close. So here 49, what's after 49? 56. Ooh, that's closer to 54 than 49 is. So I think I'm going to choose to round it to 5,600, right? 56,000, sorry. I don't know if I said that right. Because 7 goes into 56 8 times. And we'll get to that in the next one, but remember when we divide, cross off 3, cross off 3. Oh, no, sorry. Stop what I just said. Even Mrs. Berger makes mistakes. Man, that was a big mistake. It's divided by 7. So 7 goes into 56. Circle it so you know how many zeros to add. 8 times, how many zeros? 1, 2, 3. 1, 2, 3. Okay? Always good to go back and recheck. Even adults make mistakes. Greatest common factor, aka GCF. Greatest means the largest, big. Common means the same. Factor means to fit in. So the largest number that they both fit into. So for 15 and 40, you need to find all the factors for 15. 1, 3, 5, 15. Now I did it different this way. I've been really telling you guys to do the rainbow, where it's like this, 1 and 15. I would still rather you do the rainbow one because you might forget some. 3 and 5, and that's it. You get the same answers, obviously, but now what I would do is, does 15 go into 40 evenly? No. Does 5 go into 40 evenly? Yep. So 5 is going to be the biggest number that goes into both. Or you could just list all the factors too. Next, lowest common multiple, aka LCM. Multiple means multiplying. When I multiply, I get bigger. The smallest multiple both numbers have. So in this one, lowest common multiples of 5 and 7, start with the larger number and show the multiples. 7, does 5 go into 7 evenly? No. 14? No, because if I know my tricks with 5s, it has to end in a 0 or a 5. So 7, 14, 21, 28, 28 again, I guess, 35. Oh, 35 is going to be the first one, the lowest one that they both share. And if you wanted to, you could write these out. 5, 10, 15, 20, 25, 30, 35. And 35 is the LCM. Trick, start with the larger number and ask if the lower goes into it. That cuts down on your work. Sometimes they will ask you to look at 3 numbers. On the test, I know that they're going to ask you to look at 3 numbers. So if I look at like 5, 7, and say 3 maybe. Again, start with a big number. 7, 14. Does 5 go into 14? No. 21, 28. 5 doesn't go into any of these, so keep going because they have to go into all of them. 35. Ooh, 35 it goes into. Does 3 go into 35 evenly? Oh, good job, Leo. You add the digits. 3 plus 5 is 8. Does 3 go into 8 evenly? No. So now I'm going to have to keep going. I chose wrong, pretty bad ones. I know that it's going to go all the way up to 7. Wow, I don't even know. I'm not going to keep going with this one. Sorry, I chose the wrong one. On the test, it will be one that is not going to take you this long. I promise. All right, now prime factorization. Oh, I wish I could move this up. There we go. Prime factorization, finding prime numbers using exponents. And the prime number chart is right up on the board. unless I accidentally take it down or it falls down, but I don't plan on taking it down, and I doubt it's going to fall down. So know your prime numbers. Let's do a practice for prime numbers. Remember, Mrs. Berger loves these. 80. Okay, what two numbers go into 80? Let's see how many people are doing the same one that I do. I did 8 and 10. Anybody do 8 and 10? And I know that they're both not prime numbers. 2 and 4. Do I have a prime number? Yep, 2. Let's continue on with that one. 2 times 2 is 4, so I have, that one's done. This side is done. 10 is 5 and 2, and they're both prime numbers. Now you need to show them with exponents. So I have 2 times 5. How many 2's do I have? 1, 2, 3, 4. So 2 to the 4th power times 5. The same way to show that is 2 times 2 times 2 times 2 times 5. Let's do one just because I really like these. 36. Try to guess what I'm going to do. 6 and 6. 3 and 2. 3 and 2. We're done. 2 times 3. But how many 2's? 1, 2. How many 3's? 2. 2 to the 2nd power times 3 to the 2nd power. Or 2 times 2 times 3 times 3. Let's go on to multiplying by tens, hundreds, thousands. Multiplying by the numbers and count how many zeros to add. So if I have 5,000 times 400, just multiply 4 times 5. It's 20. And then add the zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There you go. Now that's a pretty easy one. It's not going to be that easy always, but there's a start. Dividing by tens, hundreds, thousands. Cross off the same amount of zeros on both sides. So here's an easy one. So 80,000 divided by 200. Cross off the zeros. Divide 2 into 8. And I suggest you circle the numbers so then you can clearly see how many zeros there are. 4, and there's 2 zeros. You get 400. Now I'm going to give you another one because it's always going to be that easy. Let's say it's 43,562 divided by 631. Wow. Now we're going to give a quick estimate. If we're going to do an estimate, we're going to look at this number first and this number. Actually, mainly this number. 6 and 43. Now this is why it's so important to know your math facts. You need to think, what number does 6 go into evenly close to 43? 6, 12, 18. Hopefully you don't have to do this, but if you do, that's fine. You're not there yet with knowing them automatically. 6, 42, 48. Okay, so 43 goes in between 42 and 48. Which one is it closer to? 42. So let's change this to 42 and add 3 zeros. Now we're going to divide it by, we're going to make this 600 because we already looked at the 6. And in my head, I looked at rounding that, and 3 doesn't give it enough power, so it stays at 6. Now cross off the same amount of zeros. 6 goes into 42. If you don't know your facts that well, you've already done the work. 1 time, 2 times, 3 times, 4, 5, 6, 7. 7 times. So 6 goes into 42 7 times. How many zeros are left over? 1. So it's 70. Good luck on the test on your English day. I know you'll do great. If there are any questions when you're doing the review, please let me know. I want you to succeed.